Hash is a micro app and API that is inspired by zero-knowledge proofs, a distributed ledger concept to solve identity fraud, phishing, and various kinds of social engineering attacks. Cybercrime is on the rise, costing Australians $1 billion a year, with 1 in 4 Australians being victimized. One example where our proposed solution can be applied is in a typical phone-based authentication scenario, where a caller claiming to be from a business requests for sensitive data from the customer in order to proceed with a transaction, such as paying an overdue bill. The customer is at the losing end data privacy-wise as they give out sensitive info for the sake of verifying who they are, even though they were the ones receiving the call. Our solution involves the use of hashing, which is the process of transforming any given key or string of characters into another value, as well as additional security features in order to generate proof that the customer is who they say they are, without giving out actual sensitive info like their address, date of birth, or full name. These screens show the request a customer gets upon receiving a call. Instead of sharing the actual email and address, they generate a hash of it via the hash button. That is shared with the caller, who verifies it with what is generated from their record. This shows what the interface would look like for the caller when launched from an operations console or as a third-party desktop app. They are able to send requests and also verify the customer's hash with what they have. Integrating into an organization's default app is also possible. The architecture involves pushing out the hashes which are generated from 2 databases, one owned by the customer and the other owned by ABC Bank. This entire process is triggered when the customer clicks hash on their Hash phone app. The hashes are generated using a tool we made called ScryptHasher, which we will talk about in the next slide. Another benefit of this architecture is that the customer stores their sensitive info in what we call a single instance database. This way, when a customer moves houses, for example, they can just update their record once, and any party wishing to update their record can pay a micropayment to make this happen. In other words, there's a chance to monetize data here. ScryptHasher is the engine behind hash, which makes use of the script function key to generate a 64-byte hash of the customer's sensitive info with the salt, which is a symmetric key, coming from a trusted third party, which in this case is a centralized database served by a microservice. Access to the database is secured using Transport Layer Security, TLS. The TLS protocol uses public key infrastructure, PKI, to exchange a one-time symmetric key. ScryptHasher takes in a passphrase and an optional 8-byte salt. Without the salt, the tool generates a random salt. You can find ScryptHasher on our GitHub. Organizations pay us every time a hash is generated, which is once a call, as well as whenever they want to update a customer's record with the latest on file. If half of CBA's direct banking calls use hash, this would save them $265,000 a month just on hiring costs via time saved, which is around 40 seconds a call. Our go-to-market strategy targets a list of 63 call center services in Australia, as well as SMBs. Having partners with roots in industry helps our cause too. Our vision for Pingo Creative Technology is to create a better and fairer world through prioritizing data privacy. Users should be able to retain ownership and granular control of their data, and businesses benefit from a better, safe experience for their customers. Thank you.